All right. So FirefoxOS game development, because we like game development, with FrozenJS.
I'm Louis Montez. My Twitter handle's right there, Montez Lou. I'm one half co-founder of IceDev. We're a consulting firm. We are a game development firm here in the Phoenix area.
And I'm Blaine. Blaine Bublitz on Twitter. You can ask me any questions or anything there. And I'm going to be the first one speaking today. So at IceDev, we do consulting, but we also do game development. And with that comes creating a game engine. So we created a game engine called FrozenJS. FrozenJS.com. You can find the documentation, how to get started, awesome stuff like that. A bunch of examples too. We talk about it a lot. So if you haven't heard of it, you should find one of our talks. Louis did one on youtube.com/hackphx. So what is Frozen? Specifically, Frozen is an HTML5 game engine. So it's all JavaScript and web technologies, all in your browser. We made sure that it's open source. It's completely open source, MIT licensed. And we want to really make it easy to use. I spend a lot of time really nitpicking pieces that might be a little too hard. And another thing that we're really focused on is getting you up and running really quickly. Even if you don't know JavaScript, like you can get the basic stuff up and running right away. And it's modular. We love AMD, so it's every piece is its own module, and you kind of just plug things together. So people looking at iOS and Android might think, oh, WebKit's the only thing. Might use libraries like Zepto.js and only -WebKit CSS prefixes. But you shouldn't be doing that. WebKit isn't the only game on the block. I know Opera just switched to Blink, but Firefox for Android is an excellent browser. They have things like WebGL, and it's like comparable speed to the stock browser. I would even compare the speed to Chrome for Android. Also, there's now FirefoxOS, and none of your apps will work on FirefoxOS if you made them only for WebKit. There's no reason to target only that. We can put in a little bit more effort in, and it'll work. So FirefoxOS specifically is a mobile OS. They want to compete in this space, and they do all of their development completely in the open. You could go check on GitHub today, and there will be commits. I have a boot2gecko device that I updated on 7/11. There's a commit message in it, and in the version and everything. So it's completely like the reason for Firefox OS is because why would we write native code? Why don't we take HTML, CSS, JavaScript, stuff that we know runs cross-platform, pretty much runs everywhere, and make that the layer, the UI layer, the integration layer, everything. The problem that Firefox ran into when they started this is that none of the device APIs were available to JavaScript, which is why people wrap things in PhoneGap, so you can access that from your web view. But they have set out to make specs for every device API. There's like Bluetooth APIs and stuff. All of it's going to be accessible with JavaScript, and all of it is currently in Firefox as like the first implementation, and it's still going through the spec process. So another thing that I really like personally is that there's no vendor lock-in. You can have your web app on the web. You could put it in the Firefox store. You could then wrap it in PhoneGap and put it on iOS and Android. It doesn't really matter because it's just web technologies. Some of you may be asking, well, why develop for a device that isn't available? While these are hard to get, they are available. Geeks Phone, they are the developer devices. They actually have two devices. I have one shown here. And they sold out in like the first 2 days. they just announced a third device that's even higher specs than their previous two. And then 2 phones just came out like in the last 2 weeks. The ZTE Open, which is in Spain from the carrier Telefonica, and Alltech One Touch Fire, which just released like last Friday from T-Mobile or Dutch Telecom in Poland. So there are devices. We can start developing. We can start making money. We can start getting stuff out. So how would you distribute on an open web OS? The cool thing that I have really gotten into in the last week, I think, maybe 2, is that you can install these from your website. We'll get into it a little bit later, but you can just put a button or a link that installs it from the app on a web page. And it makes it available offline and stuff. You can also get it in the Firefox Marketplace. This allows zipped up packaged apps, which will install the whole thing when they install it, or hosted apps, which are, again, just a web page, but they just launch like a full app. And you can get hosted apps like installed from websites apps cached so that they can work offline using things like app cache and stuff. You can do free or paid. You can even do in-app purchasing. All of this is handled by Mozilla servers. I had a long conversation with one of the guys that's writing that backend at NodePDX. Very smart guy, and it sounds like they're doing a really good job on the back end. All right, so now that I explained FirefoxOS a little bit, I want to start talking about how you can get a game up and running really quick with Frozen that's going to work in FirefoxOS. So the things that we like to focus on are tooling, right? Tooling that may or may not have been developed for web apps, like these things. Yeoman is a scaffolding framework that allows you to rapidly scaffold out a whole JavaScript project, not just JavaScript, also HTML, CSS, all that stuff. Grunt is a task runner. I'd like to compare it to Ant, but better. And Bower, which is a package manager for JavaScript libraries and CSS. To get that stack, you just have to install Yo. So npm install -g. -g puts it globally so that you have bash commands. And you just install Yo, and that'll give you the Yo command for Yeoman. And then it'll also install Bower and Grunt, so you have both of those commands. And then Generator Frozen is actually the scaffolding for a Frozen game. I have a link down here if you want to read the nitty-gritty source. But this will get you running. So how easy is it after you install to get a game, an actual game, something that's doing something, to get it ready, to get it going, right? So I'm going to move this. On that terminal, I have an example, but we're not going to use that example. So let's make dir phxmobi and cd into the newly created directory. All right, and then let's just run Yo Frozen. This is going to prompt you some questions, ask and for answers. This helps us scaffold out your game better. Things like what is the name of your game? Let's name it phxmobi. Describe it. Super awesome game. And then, like, what version? I'm very into semantic versioning, so you can't use that as a version number. You have to use something like 010. Repository, of course we're going to have it at GitHub. We're going to use Box2D because we do a lot of 2D physics games. Louis loves it. So yes, we're going to use that. I just added this question recently. Should your game be installable on FirefoxOS? Why not, right? And then if it's available on FirefoxOS, it's going to ask you a few more questions because they require it to put it into the store. And another thing that I'd like to point out is that like games on Android, because I use Android, they are usually lock your app in landscape mode when you launch them. This isn't really available in browsers, right? But Firefox is actually working on getting this as a spec to lock orientation in a certain way. So on FirefoxOS, you can actually specify to be locked in landscape, which will launch your app in landscape, just like a game on Android or iOS. So yeah, we're going to do that. This will install all the dependencies that we need. We use a lot of NPM stuff for the Grunt, and then it'll also install our game dependencies with Bower. No need to like manage all that stuff yourself, because this does it for you. So if you see, we have tons of stuff in there now. Our indexed HTML, all sorts of stuff. So according to this, all we have to do now is run Grunt. That's a game. All right, it's not a fantastic game. So let's have Louis write a game for us.
Okay, quick warning, I'm not a Mac guy. This is a Mac, and I'll try not to trip over myself too badly here. All right, so we have this game scaffolded. Now we're going to go into Sublime because we love Sublime. Everybody loves Sublime. What's scaffolded for us? So in the Phoenix Moby folder, we've got some JavaScript source, some configuration, some index HTML, some CSS, that sort of thing. Our index HTML is just basically the container for our page. You can go in and edit all of this stuff. And more importantly, here is the source to a typical FrozenJS game. But like most HTML5 game engines, we got a few things that we have to do. We're going to paint to the screen in some type of a draw render function. We're going to possibly call an update every 16 milliseconds, 60 to get 60 frames a second. We're going to keep calling this update. Okay, great. We also brought in Box2D, so we have an instance of a box game, which is a wrapper that we're using on Box2D to make this stuff a little easier. Okay. All right, so the next step that we want to do is we want to actually put some objects in this game. Right now we've got, you saw we had a ball fall onto a board, nothing, right? Since we're doing this in Box2D, we want to draw a bunch of little shapes. We're going to make just a very, very simple platformer here. We're not doing anything too complicated, but what's important here is we have some additional tooling to help us out. Now, we could just start, this is just a web-based editor that we've created to give us some JSON, some JavaScript objects that we're going to bring back into our game that'll let us define all the geometry. Now, I could just start drawing on here, start putting squares and things, but that's going to be kind of difficult since I can't really see what I'm doing. So I've already created a background for this game, for this little platformer, and we're going to use that. Let's see here. So I'm going to, let's see if I can do this. I could do this. I'm going to take some images that we have from another game, and I'm just going to paste them right in here. Okay, great. So let's look at I've got a few images. I've got a background. I've got a few other things. Let's start with the background. Okay. Can I do it? I can do it. Yay. Okay. I drew this in Tiled. Tiled is a free editor that will take little tile images, put them together. And now I could take every one of those little images and render them individually in the game. And for a side scroller, you really want to do that so that as you're moving around, you're drawing different sections of the game. But for the question is, this is the JavaScript file. This was just a PNG file. This was just an image. I just wanted to put that into the editor so that we could have a frame of reference of how we're going to draw shapes, so that we can use that geometry in our little Box 2D game. Okay, so we've got some tools down here in our editor. I'm going to draw some static bodies. The first one I'm going to do is a little rectangle here for the bottom. Now, in the editor, this is all great. I got that one first try. Well, almost. I didn't quite. You notice I don't have it over to the left enough, but luckily we have a little move tool here, and I'll try and get that lined up just a little better. There we go. Okay. There's our floor. Let's go back to create. These little boxes here, let's do those as well. And I missed that as well, so I'll move this around as well. So this doesn't have to be perfect, but you know. Actually, I really screwed that up. Let me undo. It undid too. Okay. Let me create a static rectangle again. Okay. This is what I want. I want to move that rectangle just a little bit. Okay. You notice what it's doing down here is it's creating some JavaScript objects based out of that definition, and that we're going to pull that in. So let's just do a little bit more here. I want maybe a polygon to represent that little hill that I have in the map. Yay. Okay. One more object. Let's put our character in there. Why not? A little starting guy. We're going to make a rectangle, and I'm going to make him dynamic. So I'm going to draw just a little square, not an exciting character. Oh, by the way, this is all, if you've noticed, it's a live editor, so the physics are really happening as we're going. By default, the scale that we're at, we kind of consider each pixel in the screen and every 30 pixels being about a meter. So the physics of what's 9.8 meters per second, like a falling object on Earth, that's in relation to that scale of 30 pixels, 1 meter. Okay, great. So we've got some JSON here now. And let's take all of that JSON and copy that. And, oh, before I do that, I want to show you one more thing here. This little rectangle, we automatically assign IDs because every shape in this world is going to have an ID. I'm going to actually give this one a name instead, and I'll show you why here in a second, but I'm going to name that rectangle so I can reference him later. Okay. Now, back into Sublime. One of the things that we do is we load a bunch of geometry. When we scaffold out a Box 2D game in particular, we load a bunch of geometry. If we're not doing a Box 2D game, we wouldn't have this, but to make it easier, we're just going to drop all of that here and replace what was in, replace that seed data there with our data. Great, okay. So let's save that. And I'm going to bring the terminal back here. We should be live reloading now. Okay. So, first problem, where'd all my stuff go? I just brought this new geometry in, but I don't see anything. Let me set the resolution into our canvas. So a canvas element in HTML5 has got a height and width. Now that's actual pixels. Now we can stretch things with CSS and move them around, and what you get on screen is different. But if you think of the coordinate system within a canvas, it's this here. So I'm going to make this a little bigger to fit the geometry that we made. All right, and save that, and that should also have reloaded. It did. Okay, great. Still doesn't look much better though, right? Like, okay, this is the stuff that I drew, now it's the map, and that's cool. And in fact, if we reload it again, you'll see, yeah, gravity takes over, the little dynamic object falls down. Great. Okay, let's bring some images into the game now. Okay. To do that, we're going to modify our draw function. Now, has anyone in this room done any AMD or know what this is? It's a module system. Let me just, real quick, it's a way of us defining little JavaScript modules that we can sort of bring together, that we can dynamically request, and that we could, using a build process, squash everything together and get just the pieces that we need. It's like any other programming language having modules. This is the way we're doing it. So for draw, we're basically defining a function with this AMD module, our draw function. It's going to be used within the context of our game object. So within this function, this is going to refer to our game object. But we want to, we want to draw a background in our draw function. Make sense? So I'm going to still just a little bit here. And what we do in this section of the define is we're going to use actually what's called an AMD plugin. We're going to require in, or we're going to be pulling in an image, and we're going to use that image within our code. The reason we do that in Frozen, why we'd want to do it this way, is if we name images, we don't want our game to start until all these images are done loading. So we're just going to put that as a dependency within this define, and we're going to have access to a JavaScript image object. So let's call this one background. Okay, now context here is an HTML5 2D rendering context. So in this function, it's going to be called, hopefully 60 times a second, and we have a bunch of functionality that our rendering context gives us. One is to fill rect. So fill rect is drawing a black background, but I don't want to do that. I want to draw an image instead, and I want to draw that background. And yeah, let's see here. Save that. Come back to our game. And voila, we got a background. Okay, it's still got all that other geometry in there, so that's not that cool. But at least we've got our background. You can see that where where the borders and things lay out. All right, so let's go back to our drawing function. What I'm doing is I'm spinning through all of these entities. These are all these little game bodies. I don't want to draw all of them. They're static. They don't really mean anything to us visually because we have a background. Let's do that. Come back. Okay, now we're not rendering all those little pieces, but we're also not rendering the little guy anymore because he was just one of these default renderers. So let's make that guy. Let's make a little object for the player. What I'm going to do is create another module, and this will be player.js. And I'm going to steal just a little bit of code that I wrote earlier. Okay, and let me take you through this here real quickly. What we're doing here is just another module, and we've got we got 3 dependencies. DCL is a module that allows us to do a bunch of things. That's a whole talk right there, but it helps us to do pseudo object-oriented looking code. That's one of many things that it can do, and so it'll give us a little bit of a hierarchy, so we can inherit from things easily. We can do this in JavaScript, pure JavaScript. This makes it a lot easier. So I'm going to define a player object. So don't get too hung up on the syntax. It's a little weird right now, right? Like we're returning a DCL. What that's actually doing is it's returning a constructor function. So this module is going to return a constructor function for our player object. So with that said, I wanted to add a couple of little attributes to our player. Some linear damping. That means is we don't want things to continue to go forward when you move them around in Voxd. You want them to slow down. Angular damping. I want things to not rotate so much either. But most importantly here, I'm putting in a draw function because I want this player to render with an image and not just that little box that it was doing before. So I brought in a player image, and I'm going to use the context the same way I was doing the background. I'm going to draw an image for just the single player. context drawing. I'm drawing this particular image. I'm doing it at this location. Remember, I said that in Box2D we're scaling as well. So these entities, once we've put them in our box, they're in that 30 pixel to 1 meter coordinate system. So our pixel sizes change and all that. All that really means is that I've got to scale where I'm drawing the thing out, and that's why I have this the X location times its scale. Also, when you draw an image, you're drawing it at the top left corner. So I want to move it over a few pixels. That's what I'm doing, so that I've got the image centered in relation to where the body is at. Okay, great. So now we have a player object. But how do we use them? Well, right now we're not gonna get anything. I've just defined a module. I didn't bring it into the game. So let's do that. Let's bring him into our game. So I'm going to include that player object. And if I do any obvious typos or anything, just yell at me. I do that a lot. Okay. So there's our player constructor, which got returned from that module. Okay. In this game, after we've brought in our box data, all that data that we had exported from the editor, we're just sort of spinning through all the things that were in that array of objects, and we're adding them to Box2D. So what I'm going to do is, remember I named one of those things to give a specific ID of player. I'm just going to check if the entity.id is player. Then I'm going to add a player, not just a rectangle or a square, or I mean, not just a rectangle or a circle or a polygon or whatever. Oops. Okay. Instead of just any new entity, I'm going to do a new player object. Okay. Let's see. Where are we at? Okay. Boom. We missed something. Okay. What's that? Oh, else if. Yes. Okay. Still, we're not rendering him. Why aren't we rendering him? Because in our draw function, I didn't render him yet. I told it to not render for all the entities, right? But what I could do is render a specific one. I can get rid of all of this stuff here. I could do this dot entities. Once we've added that player, it's our entities is a map. So we've got now a player property since we've added him to our box. All right, so should be able to just draw yeah, and it'll know where to draw because it's got a reference to its location. Sure enough, there's our little guy there. Okay, so I've got a little character on here, but still we've got no control of anything here. So the physics work, right? I mean, he just fell and he's standing sort of there on the grass. We want to move him around. Now, if I'm building something for a browser, I might want to hook into some keyboard events like move arrows. We have a gamepad API we can use in HTML5. Now, that's pretty cool. So we've got all of these things that we can do, but we're targeting FirefoxOS with this. So what should we do? We should use some sort of a touch interface, right? With FrozenJS abstract mouse and touch events a bit. So by default, we're going to emulate the mouse with touch. So we're going to code for a mouse here. And on a touch device, iOS, Android, FirefoxOS, we'll get those events. But what's interesting, though, and if anybody here does game development on a small screen, you really got to take a lot of considerations onto movement for a little character or any type of character. You don't want your hand in the way, basically, what it comes down to, right? You don't want to be moving the guy around with your finger where you can't see him. That's awful. That's a horrible experience. So there's lots of ways to do this. We've got a golf game, a mini golf game. one thing that we do is it's the only thing that we're moving around, and all we do is we just launch the ball at the hole, and we could touch anywhere on the screen and sort of I guess swing a virtual putter that way. But for something like this, for a platformer, we might have a couple of controls. We'll start with one control would be to move the guy around left, right. Now, to do that, though, we want to put some virtual controls on the screen. So let's do that. And to start off with, we just need to draw something on the screen that says, here, draw the controller here, basically. And draw it in a place that's out of the way. Okay. All right. So what I'm going to do is I'm going to set a point on our game. Now, how you control the state of your game, there's no one right way to do this, right? We might have everything belongs to our game object. We might have some other state objects. We might have some level objects. How complex your game is, whatever, is going to determine how you manage that game state. You're on this screen. No, now you're in the menu. Now all that stuff. For the purposes of a very simple platformer here, I'm just going to go ahead and use the game object itself to maintain our state, which means I can just sort of plug things into that game object. In JavaScript, right, it's loosely typed. We can just add properties to whatever. So let's go back to our game object. And what I'm going to do is put just an X and Y point. The coordinates of basically where I want my little controller to be at. That's cool. So we can save that. Oops. Yeah, we didn't buy it yet. All right. So we know where we want the thing. So our game object knows where, but our draw function needs to bring in some type of controller image. So I'm going to yet again bring in another image here. Okay. And in our draw function, I'm going to make a reference to it. I'm going to use the loader. I've got a little crosshairs image that's going to work as our controller. Okay. And let's see here. I'm actually got more cutting and pasting I could do. We don't need this thing anymore, so I'm just going to go ahead and remove that thing spinning through all the images. Okay, and we're going to draw our crosshairs. Now, I'm going to draw the crosshairs at the center. So I'm basically taking the image's width and I'm moving it over half and moving it over half. It's a little square image. Let's see. Okay, so that's our little controller. You've seen this in mobile games, right? There's a little circle or something that says this is where you put your thumb to move stuff around. That's that. Okay, that doesn't give us any control though, right? I mean, that's just drawing a picture. So let's actually handle some input. Now, we could, in our game, specify an input handler. I'm going to make this yet another module. It makes sense after a while. The more AMD you do, that you'll really want reusable little modules, or at the very least, you want to separate your code so that you don't have just huge monolithic single files. Handle input sounds like a good function that could just be in its own file. So let's do that. Let's create a new file. And we'll call it handle input.js. Okay. Okay, now there's a little bit of more logic in exactly how we're going to handle the input than simply drawing something. But okay, so I've got a couple of utilities that I'm going to use that we have in Frozen. Just some simple math functions. So I'm bringing in my define the distance formula and basically a little formula that can tell me with 2 points what is the angle between them. And so I'm using those utility functions, distance and degrees from center. Now, what I want to do is only move around when I'm near the controller, that little circle that I just added. So this function is going to get called every iteration of our game loop. And we're passing in input manager, which is just this object that sort of helps us with things like get hold of the mouse, or just different or keyboard and things like that. And we are emulating the mouse. So we're doing just a single point here, a single touch point, and that makes sense. We can by default just emulate the mouse. So when we're playing it on a desktop, we could use the mouse. If we're playing it on a mobile device, we can use the touch action. We can use the touch as a mouse. Okay, so if the mouse is pressed here, I'm going to check what the distance is from that touch point to our little crosshairs. And if that distance is significantly small enough, I'm going to say, okay, well, what angle is it at? If it's so if we could, in Boxity, we think of things as 0 degrees being at the top, right? So, and then we're going to go clockwise. So 90 degrees, would be, to the right. So if I'm within like 45 to 135, if I'm moving in that direction, or if I'm close enough to the controller, but my thumb is over to the side a little bit, I'm going to apply an impulse to our player to the right, or 90 degrees. If it's 215 to 335, so sort of an angle on the other side, I'm going to apply an impulse at 270, which is to the left. So, and right now, I created this function, but I still got to plug it back into our game, right? So let's do that. Oh, yeah, I should save that. Okay. I'm going to put it up here with my other utility functions. My other game functions. Handle input. Right, so I'm requiring it in, and then I'm naming that thing as a parameter to my AMD module here. When you're first getting started with AMD, this will trip you up. The order of these parameters, or maybe forgetting to put a parameter, you required it in, but you still got to name it down here. Input. Okay. The game itself right now has a handle input function that's a no-op, so we're going to override that in our game and use the handle input that we just defined. And let's see how that goes. Okay, so we can move the guy left and right. And I didn't put any walls over here, so he's gone. Yeah, forgot about that. Usually when I'm doing a simple like 2D, a box 2D demo, I'll draw a box around everything first so none of the objects get lost. But whoa, not this time. That's okay. The same thing's going to happen if he goes the other way. Ooh, there he goes. Okay. Now, so that's cool. And if we did this on a device now, we could just use our thumb. It's out of the way. It's in the corner. We can move the guy left and right. But you notice also when he's moving, he's not really. It doesn't look like he's walking. It looks like he's gliding, right? So we want to use some animations here. So let's do that. I've got a sprite sheet. Oh, by the way, all of this art just came from what's the name of it? Open Art Bundle, right? So they had sort of a Kickstarter type thing where they not just opened all this stuff. It's like public domain now, so it's cool stuff to use. All kinds of really cool looking 2D art like this. All right, so let's get some animations going. All right. So our player, we want the player to render a little better than just a single static image. I think the static image is probably cool if he's just standing there, although an animation of him like looking at his watch if you're not doing anything or something might be kind of cool too. But let's just get the guy moving. Let's get him walking. Okay. All right. So I'm going to bring in another image. Okay, and make sure to name it on here. I'm actually going to call it walking image. Okay. Now this image is a sprite sheet. It's a series of 11 frames of a character, and it's in a loop. So by the time it gets to the end, it's just capable of looping to look like he's walking. A small problem that we have here, though, is I don't want a walking left and a walking right, because this looks like he's walking So it looks like he's walking to the right in this image. But if I'm walking to the left, I want a different series of animations. The easiest thing to do here would be for us to just flip that walking image so that it's still a series of 11 images, but if it's flipped the other way, it looks like he's walking to the left. And we have a... Oops, sorry. Okay. We have a little helper to do that in our library. We can flip images left and right, and or flip them on the X, flip them on the Y. And what I'm going to be doing is using this resource manager. Oh, real quick, I'm using something, but if I don't bring it in here, I'm not going to use it. It's going to be a undefined object error or something like that. So I'm going to bring in this resource manager, and we put it in the right place. Oops. There we go. Okay. So when the image loads, we flip it. Now we got a left version of it, and we want to create. I'm going to create a couple of animation objects. Okay, and we also, one more object here, sorry. I need an animation, and this animation module to maintain these. Good, and okay, cool. So I've added a couple of properties on here. A walking animation and a walking left animation. The parameters are pretty simple. It's how many frames, how much time do you want to spend on each frame. You could tweak all this stuff, but this is 75 milliseconds per frame, which image we want to use, and the height and width of each frame. So we've got those. Now, okay, great. So we've got some animations, but we have to change our drawing function up. Because right now we're still, in our draw function, only going to be drawing the single image. So let's change that. Instead of drawing the single image, we can here we go. Oh, that looks nice. Okay. We can look at the linear velocity at any given point of any of these Box 2D objects. So our player is going to have a linear velocity with an X and Y component. And this is, I believe, it's in meters per second in relation to the whole Box 2D coordinate system and units. So if we're going more than a meter per second in the positive direction, let's use the walking animation. If we're going in the negative, less than negative 1 meter per second in the X direction, let's make him look like he's walking left. Otherwise, if he's not moving X or Y, we can just use that same standing still image. Okay, and those animation objects that we created using this create from sheet, they have a draw function. They also have an update function because we want, every time some amount of milliseconds pass through, we're going to want to update those. Okay, so at this point, let's do this. We are still moving around here. Notice it looks like he started to move, but it's not really animating yet. That's what we have to update these animations. Okay, so let's do that. We have an update function. So we have a draw function, we have a handle input function, all in their own modules. Let's do this to our update function. Because I had that. Okay, here we go. Okay, so we're passing in milliseconds to our update function because this gets called every game loop. And what's really important here with passing in milliseconds, the number of milliseconds can be different every time, depending on how fast the machine is. Now, really, underpowered mobile device, it might be, more than 16 milliseconds each frame. So you might want to do something like advance the player a little further, or advance the animation a little further. So yeah, things will get a little chopped up and a little janky, but at least things won't slow down in the game. They won't look visually slow. They'll just be a little choppy. Right. Yes, absolutely. The question is why we would update both functions, and we totally don't have to. I could put more logic. I was just trying to keep this a little simple here, but we could totally keep logic that says, hey, only update this, the right one if I'm going to the right. But these animations it's really just incrementing a counter, and it's about the same. Like, we could just go ahead and speed through. It would be better because if maybe you're on the 4th frame of the animation, then you turn the other direction, and then you come back, should you still be on the 4th frame? It might be important. Might not. Yes, pre-optimization is the root of all evil. Okay, so, great. Let's go back into Firefox. When we move things around, yay, now he's running. And he's running up on these things here, and he's falling down probably too slowly, so it looks like he's floating a little bit. But, okay, so we've got a guy to move around and stuff like that. We could, if we apply an impulse up. Or maybe we put a different button on here, so we could do everything from here, right? This is just basically scaffolding out the beginnings of a game. We can put a score up top, and there's a draw text function with context, but maybe a score up in the top. Maybe grab a different object as an enemy. We have collision detection built into the engine, where we could just, every iteration in our update, we can say, hey, has he collided with anything? Did he collide on the top, like in Mario hitting a mushroom? Let's smash that guy. All of that stuff, right? And so what I'm hoping to do is just sort of get you guys through where we would update objects, how we would bring more things into render, and just sort of how the game loop works. So we've got the basics working now in something that should work in Firefox, and we should be able to control in Firefox, because we've got touch events, the little controller isn't in the guy's way, and we should be able to start debugging this stuff in FirefoxOS. And with that basic simple platformer thing sort of scaffolded out here and built and animating, I'm going to give it back to Blaine to talk more about how we do this stuff on Firefox OS now. This thing will render in Chrome. Well, we've got actually a list of supported things. For the most part, depending on what you're doing, anyway, you got an HTML5 canvas, which has been iOS for a long time, Android for a long time. Even IE9 has a canvas. Yeah, Chrome has had it forever. Firefox, actually the first place I saw it show up on was Firefox, and when I first saw that there was an HTML5 canvas, I'm like, oh, we could make games out of that. Once you have the ability to put any pixel of any color you want on the screen without needing to load up a plugin like Java or something, wow, we can do games in a browser with, open standards. So yeah, totally, this stuff. Now, all kinds of considerations, performance, all types of things to consider when building for different platforms. But the basics of this stuff should work. It's HTML5 and JavaScript.
So this talk is on getting these games in Firefox OS. And it was really cool that Louis could show creating a game that quickly. But something you may have noticed the whole time is the Install with Firefox banner. This is actually installable, and we'll get to it. It was just, I really wanted to mention it while I was sitting down, and I didn't. So, write your game. You wrote your game. Now we got to test our game. And this can be painful. Firefox has kind of made it easy, but there's like a disparity between browser versions. So that part is a little bit annoying. One cool thing that they've recently released, and they just released a new version, is the simulator. So that game that Louis created, let's just open it. So let's go back to examples, Phoenix Moby, It has to have a manifest web app, which we already scaffolded for you. All right, there's the Phoenix Moby game. Oh, and there's the emulator. So we chose to lock it in landscape mode. The emulator doesn't handle it perfectly, but it at least locked it. It showed us how it launched and locked it. On FirefoxOS, it's actually the whole screen. It full screens it. But you can see that it's here, right? You can see that the guy is moving and lost off screen. And back! He's crazy. So you can actually put your app in something that works exactly like FirefoxOS. And by exactly, I mean exactly. Not only that, but we can click connect here, and it's going to relaunch that emulator. But if you notice, down at the bottom, it connected to Firefox's debugger. So we, in our generic game scaffolding, we console.log the game object, so you know that everything that's there. So if you notice, here is our game with everything. That's all the box data. That's everything. So you can actually debug it from your Firefox console in that simulator, which is really cool. Let's close that. And in the new version, they actually just did receipts for paid, like in-app purchase and stuff. So you can mock those out in your simulator. There's also Firefox for Android, which works amazing. I would suggest that you don't install the standard Firefox or beta Firefox, that you go out and grab Aurora. I feel like that is a better representation of what we're going to end up with on FirefoxOS. And even though you can do most of the things in Firefox and Firefox Beta on Android, Aurora is really where it's at. You get things like web audio, and really you get the future. If you have all three installed, even if you install it in Aurora, it launches, from what I can tell, in the basic Firefox, like the standard version. So that's why I say don't install those other two. And I haven't tested that either, so it might still launch it in the old version. Who knows? Also, you can test on desktop Firefox. We've been developing this whole game in desktop Firefox. Firefox does a really good job of trying to keep a consistency. So as long as your version numbers kind of line up, you're pretty good. I believe that Firefox OS 1.0 was Firefox 18, from what I read on Wikipedia. So that could be a pain, because they're up to like 21 or 22 now in desktop. So you can have some disparity there. All right, now that you tested it, it totally works, right? Let's publish it. Oh wait, we forgot to test one thing. I really want to do this. Do you want to install it? Yes, I want to install it. See up in the corner? It's installed. Now let's use this. Phoenix Moby. Oh, come on. Why didn't that work? Applications. There it is. That app. Oh, what? That's like a native app. I just really wanted to show that. I've also been having some problems with this. There's no way to uninstall, so you have to delete the .app from your applications, clear your trash, because it still thinks it's on your machine, and then you have to go into profiles, library, application support, Firefox profiles, and delete the JSON file to know that it was ever installed, and then you have to kill the browser and bring it back up to get the banner to show up again after a successful install. That's a pain, because it should hide. Yeah, so So the banner's gone now that we installed it. There's some problems, but they're working on them. All right, so how do we publish? One thing that you do need is you need your manifest file to be served with the specific content type header. And that content type header is X web app manifest plus JSON. This is they're working on making it a standard or getting it in. And currently GitHub Pages serves .web app files as this header, or with this header, which is excellent. You can just put your game on GitHub Pages with these two commands. Just check out your GH Pages, push it to that branch, which generates the static content, if you've used GitHub and GitHub Pages. There's also, like, if you're using Nginx and stuff, there's a link on the bottom for configuration to get this to work. So let's publish it. Like, we created this game. I'm not going to push to GitHub Pages right now, but we actually have the version Louis created earlier where there's walls and he doesn't fly away. So here is it, and it's on GitHub Pages, our blog, .FrozenJS, in the examples folder. We can so I actually have the manifest here. Let's just go back to it. So there's the generic platformer. And if we do copy this and bring it to the validator, which I already have open, paste in our URL, we have to add manifest.webapp, and they're really picky about having HTTP for some reason. All right, so where? Oh, they're really picky there. So okay, let's validate. It goes and fetches it, runs it through their parser to make sure that it'll work. I failed with 8 errors. I don't know why. It worked before. There we go. I passed. Timeout or something. And then you can click and you can be like, oh, check out the validation report. And it's like, if your name is too long, it might get truncated. But it's valid. So that's awesome, right? That means, and we tested the install anyway, so we kind of knew that it would already work, but we just wanted to make sure that it was valid for the Firefox store. Now let's submit. So you log in with Persona, and I really like the Persona flow. Super easy. You agree, you sign their agreements, and then you get to this page. And you just select if you want a paid app, which only works on FirefoxOS, or a free app, and you can have that on every device in their marketplace. It can be, like, you can go to the marketplace on Android and install apps, and they install to your desktop. Yes. Does that create separate builds for every device? So the question was, does it create separate builds for devices? And no. So in your manifest, you actually specify the different icon sizes, but other than that, it's up to you to do resizing and stuff. So what we found out with Frozen is to start with a higher DPI, shrink down. If you install and cache, at very least, if you're doing a hosted app, if you do an app cache, it's one-time install, pull down. They fetch the resources on install, so having larger things and going down in sizes, it should be fine. Again, just test performance and stuff. And yeah, you just select what you want, give them the URL to your manifest again, and validate it. Once it's validated, publish. I'm not going to go do that because I don't want to have generic platformer published. But that's the process. You can get a free app out there that's JavaScript and HTML and in, an hour? Some more resources. There's tons of resources on MDN. I've had so many tabs open the last couple weeks working on this stuff. Like app manifest. Find out all the properties that you can have in your app manifest. There's just a crazy amount. Figure out which ones are required. Packaged apps, like zipping it up and actually giving it to Mozilla to host. if you do that, there's some properties in the manifest that you want to set to marketplace so that they can't be installed from other places. The marketplace has an API, and I'm really excited about this because we could, from the command line, we could submit your app or validate your manifest, right? We could just hit that endpoint with the URL, and it would do it for us. And I kind of want to integrate that in with Frozen, or in with the Frozen tooling, at least. And then there's a FirefoxOS boilerplate. I was reading through it, and I don't really like the code, which is why I rewrote most of it, or rewrote the parts that we needed in Frozen. So Frozen has my interpretation of that. And the slides, blog.frozenjs.com, FirefoxOS FrozenJS. And it's 1 hour, 43 seconds. Any questions? So the question was, what is FirefoxOS boilerplate? It's the basics that you need to get started with kind of just an app. But I took it, and I took some of the ideas from it and put them in our scaffolding. So like they have your HT access file if you're dropping it into Apache. And a fallback page if it can't find network, stuff like that. And then just like the default manifest.web app, stuff like this. So most of that is, or all the good stuff, or all the stuff that you need is handled by the Frozen generator. But if you just want an app, this will work also. And somebody took this and created a Yeoman generator, so you could scaffold out a simple app also. Anything else? Yes. The question was, what is required to publish a paid app? I haven't done it yet, so I don't know. I noticed that there is a payment keys thing, and I haven't generated it yet, so I'm assuming you need to use that in your app. And if somebody steals that, they're just giving you money, so... Yeah. Commit that to your GitHub. No, I don't. I don't know what they could do with it. Maybe they could withdraw. Who knows? Don't do that. Yeah, so I haven't done it yet. We might experiment with our mini golf game in the future.
You have that game controls?
I do. Is it on? It's on Frozen, right? You had a question also. So the question was, what are the price ranges on the phones? So the ZTE Open, which is available in Spain, I heard was like $90, which was $30 less than the low-end developer device. So that means the developer device was like $120-ish. The high-end developer device was almost $300, I think. And I'm not sure what the price is on the Polish one. I'm guessing somewhere in the $100 range. Oh, yeah. So the goal of FirefoxOS is to target the low-end market because they feel it's more about apps and running well on the hardware. So being just a HTML, JavaScript, CSS layer, they don't need a JVM. So it runs wonderfully. Actually, I can pull up a game on my... yeah, so, and you can access all the device APIs, the telephony stack, the Bluetooth stack, everything. Yeah. Another question. So the question was if we've seen any difference between testing the browser, the Boot2Gecko Flash device, and like Firefox or Android. I'm going to add the simulator in there also. They all have differences. they aren't as miserable as I was led to believe developing for multiple versions of Android has been. But there are quirks, like you saw with the emulator where it didn't go to the full screen. The Firefox for Android doesn't respect an orientation key in your manifest, and we have code to work around that. So we have some JavaScript that kicks it into landscape because it doesn't respect the manifest. I think that, like, I haven't tested the Aurora theory that I stated, but I would guess that Aurora would be probably more likely to respect the properties in the manifest than kind of older or current gen browsers. Like I said, that's untested. But yeah, everything has their own little quirk, and I'm finding them and I'm trying to work around them for our games. Yes. So the question was, are they going to make ASM part of, or are we, or is Firefox? So Firefox is it's the same browser. It's just ported to run on top of different environments. So ASM will be on the phone. ASM might be on the latest version of like the Boot to Gecko, like actually pulling down the source code and building it. It might be there. It will be there eventually, if it's not already. And I'm assuming that the FirefoxOS official devices are going to be updated less frequently, like push out updates. They're probably going to be versioned. But that's why you can flash anything that runs any like Google phone that Google actually released, like the Nexus S, Galaxy Nexus, Nexus 4, I think those three devices for sure are supported by just flashing a built source code. So this is mini golf, and it's not finished. We're going to get some more art in, but we have a pixel artist doing art for us. Yes. I know. So this is the game that we're developing, and we have, I think our artist has drawn over 18 holes. I think probably like closer to 21. Yes.
Yeah, we also just changed the resolution of our images, so a lot of stuff is it's under a lot of development right now. We had a stable version on the Chrome Web Store for a while, but it's old artwork, and yeah, it's getting a facelift, and the text isn't done yet at all.
Yeah, and the arrow and stuff, but it's in a playable state, and also this level. Oh, that level totally worked. This level has a hill, so if I can do this right, oh, hill.
Oh yeah.
Mm-hmm. So that's stuff that Frozen abstracts. We go to HTML5 audio if web audio isn't available, and Firefox is adding web audio. So that's again why I said to use like Aurora, because they have web audio. Currently, we're using an old version of the standard, so we need to put a patch in on Frozen. But yeah, so this is kind of the game that we're working on. I really want to get to hole 9, but I'm not going to waste you guys' time. Yes. Question was, are there any non-phone devices that are running Firefox OS? And I don't think so. I had heard that they have a plan now that they're on phones and they're released to get it on tablets. I would think that you would be able to put it on a Nexus 7, but I have no idea how. They probably don't have it as part of their build process or anything. I haven't seen it anywhere. But yes, tablets are on the roadmap. So Yeah, from what I heard, they want to do it rather quickly now that they have released phones. The question was, have they tried running the OS on iPhone hardware? I'm going to say not that they announced. I don't know. Like, so the reason to do Android is they actually use ADB to access the device hardware. So you're actually flashing over ADB. So that stays. And if
So which means that it's not, they're not putting a single OS from the base.
you're putting, so I don't know exactly what layer ADB is, but you're putting pretty much the whole OS. Like, you're putting the Linux and then the Firefox and then, or the Linux, the Gecko, and the Gaia. So you are flashing pretty much everything, but ADB still exists as the bridge to reach the device. They also target specifically the AOSP devices because you can download the drivers. They are still blobs, but you can download them from places legally, which is good for them, good for their developers, stuff like that. So, yeah, that's why they're targeting those devices as the flashable ones.
Any other questions? Thanks for a wonderful presentation.